In addition to binding, of course, enzymes do chemistry, and we're not quite ready to jump into that chemistry yet, but I want to introduce you to an idea that some enzymes require additional parts called cofactors to be functional because amino acids themselves and the R groups, the side chains, have limited reactivity. Those R groups are really good at doing acid-base chemistry and covalent chemistry. And of course, they can also do things like ionic interactions to kind of help in the catalysis. In these cases, the protein is the catalyst itself, but those R groups cannot do all types of chemistry. Particularly think about like redox chemistry, transfer of hydride, right? Those things are not possible just with the protein itself. So in comes the cofactor. These are various types of molecules required for the activity or required for the chemistry. They can be non-covalently associated with the enzyme. They can be covalently associated with the enzyme. And in this case, the cofactor itself is the catalyst doing the chemistry. And so we have some additional vocabulary to learn here. When we have an enzyme that requires a cofactor, but it's without its cofactor, we call it the apoenzyme. It is then inactive. But once we add in that cofactor, we call it the holoenzyme, and this is now active because it has the cofactor, which does the chemistry. To wrap up our discussion of cofactors, I'll just introduce you to a few different types of cofactor. We can have metal ion cofactors, for example, copper or iron or zinc. We'll see an example of an iron-containing cofactor later when we talk about the electron transport chain via iron-sulfur clusters. And because some enzymes require metals to work, this means that when the metals don't work, problems occur. And this is really the root of things like heavy metal poisoning. Other type of cofactors can be organic molecules, maybe smaller organic molecules or larger organic molecules. Now there's a bunch of other vocabulary for these cofactors. You don't need to worry too much about this additional vocabulary, but it's here for you. If that cofactor is really strongly associated with the enzyme, it's almost a part of the enzyme, we call it a coenzyme. If it's very transiently associated, it comes in, it comes out to do its chemistry, it's almost like a substrate, so you call it a cosubstrate. Common examples of this are NADH and NADPH. You will see these a lot later this semester. And I've shown you an example of this on the slide here. So on this slide, we have, of course, the enzyme. The enzyme in this reaction is alcohol dehydrogenase, and we have its substrate called ethanol. It uses a cofactor, NAD or NADH, to do its chemistry. Probably we, in this case, would call it a cosubstrate, but it is a cofactor, and I will be using most often just the word cofactor in this class. Finally, there are other types of cofactors called prosthetic groups. These are usually quite large organic molecules, like heme. We've already learned about heme when we talked about hemoglobin earlier this semester. These large cofactors are oftentimes covalently linked to the enzyme. And these are some of the common types of cofactors used in enzymes.